show of some of the background model slides from another presentation very briefly to get our heads back into what we're going to talk about today. And then we'll jump into some of the nuts and bolts of the inputs in the uMngeni water model or UUW model. And yeah, and please jump in with questions anywhere and everywhere. I am going to be flipping back and forth between like some slides and some Excel files and some GIS files to show you some different things. Yeah. And yeah, feel free to stop me at any point with questions. Also, I think maybe I should do that. Is Sharon here? Are you joining in any groups? I can see the names that are online. I don't see Sharon here, but I don't know if she's with somebody else.
Oh, hey, Julia, she couldn't join us. She has a commitment somewhere else.
Okay, no, that's fine. Just she had a technical question on an error, and I thought we could look at it together, but it's particular, I think, on her computer, so I won't go into it if she's not actually here. I will email her separately. I just thought if she is here, we can spend some time on that as well. But we'll come back to that. I just wanted to check if she's here. All right. So just to get us started again, to think about this modeling. So we spent the last sessions looking, like getting to know the SWAT model and how it does things, how we put it together. And so as a quick overview of that, again, we set up the model as a structure with a stream network that's fed by subcatchment areas, and the subcatchments are broken up into upland and floodplain landscape units that are in turn broken up into hydrological response units, or HRUs. And the HRUs are, each one is a soil type and vegetation type, and if you want, a slope type combination. So those are the units at which a lot of the processes are going to be calculated, and then things get accumulated into the streams. And then there's aquifers also, and those are at the scale of the landscape units. So within a subcatchment, they'll have an upland and a floodplain aquifer unit. So that's the structure of how things are put together. And we did the last time we met, we looked into the not in this one. Okay, yes, we looked a bit into the delineation of how the subcatchments were set up for this model. And so using the digital elevation model to delineate streams, and then determine the floodplain, the lowland areas, and then break the area up into subcatchments based on points where there's stream flow and water quality monitoring points, major reservoirs, and stream confluences, quaternary catchment outlet points. So points where we might want to get particular outputs. I need to correct, I meant to correct this. Sorry, this number is incorrect, the number of subcatchments, because SWAT Plus allows you to get outputs within a subcatchment, and I'll show you that. So there's a bit fewer than 160 actually. But we talked about the climate inputs. I've input them from HydroNet for the rainfall, well, actually for everything, at the grid cell level, the level of the grid cells that HydroNet produces the data for. So we talked about this last time. There are some gaps in the HydroNet data, so I patched those using chirps. I corrected the chirps to some degree based on the relationship between the chirps data and the HydroNet data. So that's the climate input. And so today what I wanted to go into was the other inputs into the model. So I'll just move to that presentation. Oh, the date is wrong, excuse me. I'll do some modifications on the version I share with you. So we talked about the climate inputs last time. Before I jump to today, I wanted to talk about some of the other inputs, but is there anything on what I just mentioned that anybody wants to ask before I move on? We're good. So today I wanted to focus again on the input data preparation and some of the setup decisions I made. And then next time we'll look at the outputs and calibration. So I was curious to hear if people had engaged with that tutorial model and gotten it to run, and whether or not I should include some time to answer anybody's questions about that, if anybody's been able to look at it further on their own.
I was able to run it, but haven't analyzed the outputs yet, but the model did run.
Okay, that's great. That's great to hear. Yeah, so when you get time, the tutorial is nice to look at in terms of it being a smaller model that runs fairly quickly. Like for example, the version I now have for this catchment takes, gosh, about an hour to a bit over an hour to run for 10 years. Just as an example. So it's it can vary a lot by how complicated the model is. So that's why the tutorial is a good one to learn with and play with there. So we spoke about the climate inputs last time. I'm going to talk about land cover and a bit on land cover management inputs, soils, aquifers, reservoirs, and dams. And as I said, I'm going to be flipping back and forth between, reservoirs and dams and point sources, back and forth between a few different file types and stuff as we talk through this. I think I'll do an overview first, and then we can come back to details on any one thing. So I'll start with land cover. Oh yeah, it's an overview of where inputs are coming from again. For land cover, national land cover mapping map data set, and then getting cover class properties from SWAT database as a starting point, and then also comparing to some accrued databases and other sources to try and get the management data. And so as I go in, if you know of other sources to be looking at on these things for your specific areas, especially the irrigation and fertilizer applications, I've generalized things quite a lot. So if you know of better more local sources that you could point me towards, I can alter based on that. And then soils, maps, and properties. We'll get into how that was generated. Then aquifer properties are coming from, I'm using information from the National Groundwater Assessment and the Council for Geosciences basic properties and mapping to get starting inputs, but then we modify them based on how the model's performing to see whether we can improve the fit to observed. And then the dam dimension, the reservoir dimensions, and the outflows. And then the point sources and water quality data I've been getting from UW. So in this process, we will be talking more about calibration, obviously, next week. But I just wanted to put this up as a bit of a primer as we talk through some of the other inputs to think about what are the properties and what are the values we're going to want to be looking at and changing in the model This is from a hydrology point of view, and then there are others on the water quality side. With the water quality, it's particular, like the most sensitive ones are, the most sensitive inputs obviously are the point sources and what data we put in for that, and then like the fertilizer applications on the landscape, more than these more sort of conceptual or other properties that are quite uncertain. So just to show these briefly, there's different SWAT parameters that control sort of how much surface flow is generated from and assigned at the land cover type. So a curve number will be one of those, and then like the overland flow roughness of the cover, and then the evapotranspiration is highly controlled by things like the canopy interception storage and the leaf area index, how deep the roots are, how the soil, how evaporation can come from the soil, the properties of there's a property called EPCO, which I'll talk to more about, the plant transpiration compensation, and that determines how much the plants can draw from deeper soil layers. And then there's another parameter that is how much the plants can draw from deeper aquifer layers if the soil doesn't meet their demand. So you can allow them to do that or not, depending on how deep you think the roots would be for that vegetation type. And then things like soil, and then from the soils, there's the soil depth is quite an important one. Available water holding capacity, the conductivity of the soil, and then something called the percolation coefficient, and that controls how much water can drain from the soil into the aquifer, the rate that it can go, to represent what we think is happening between the upper soils and where the aquifer is, all the material that's in between there, and if it's blocking recharge at all. And then from the groundwater point of view, there's once water's in the aquifer, there's parameters that control the recession constant, the threshold depth at which you start getting flow out of the aquifer, and the delay that there is for the flow coming out. So all of these are just, I'm showing you these, they'll come up again and again as we go through, but these are some of the parameters to focus on when we're working on the inputs for the model. There are quite a lot of other parameters in the model, as we've seen, but these are ones that frequently have high sensitivity scores. So to look at how we do the land, I wanted to go through some decisions I had to make on the land cover inputs and get any feedback you might have, if you have any, for this edition of the model. So I started with the national land cover for 2022, using the highest, as you might know, the national land cover mapping, they have different levels of classification. You can see a bit of a snippet of that here. So there's one level where there's only 9 classes, I think barren land, built up and cultivated. And then there's a level with 24 classes, and then there's a full 73 classes. And I looked at these different divisions, and 73 classes is too much. For each class in the SWAT model, you would need to give it a set of parameter values. Those the leaf area index, root depth, all of those things. And we don't necessarily have those or understand them well, or need to differentiate between them for 73 different classes. Also, if we used all 73 classes, I think there were like 50 some that occur in our area. If you were to use all of those, you would have way too many HRUs in your model as well, and it would take a very long time to run. So we want to lump them, but looking at the 24 classification, it lumps some things that we actually want to keep separate in our model as well. So I had to do my own reclassification of the 73 classes. So for example, like, the the NLC 24 class, it has a class that's permanent crops, but that permanent crops like orchards and sugarcane are lumped together, or it lumps other things that we would like to separate, particularly for the crops and some of the urban built-up cover as well. It lumps, all of these into residential, formal and informal, which we might want to keep separate for other reasons when modeling here. So it's not straightforward to use any of the existing classifications, but I still chose to use the National Land Cover Dataset as the starting point so that those, as it comes out in new years as well, you could update the model, but you just have to apply the reclassification logic again to make the updated land cover map. Yeah, please stop me if that's not making sense, but that's why, yeah. Or if you have other things to add about this. So I took oh, sorry, this is another slide about what I just talked about with more zooming in, apologies. Yeah, so as you can see, like these classes that would be lumped that we don't want to be lumped, but then there's other classes that we could lump that are not lumped. So this is, I'll go through the way that I did it, and some of the other limitations, as I mentioned, yeah, that are the crop types. A limitation of the National Land Cover Dataset is that it doesn't differentiate invasive alien vegetation. And so I haven't, there'll be woodlands and forest mapped, but it doesn't give you an idea of whether that's invasive or indigenous. Because they didn't try and it's complicated to differentiate that in a remote sensing context, but people are getting better at it. But those are separate projects that haven't been incorporated into the National Land Cover mapping as of yet. So if at a future stage we wanted to actually look at invasive alien vegetation as a separate land cover, we'd have to bring that in some way from another data source and add that into our mapping and our model setup. Another limitation I found with the National Land Cover dataset is that it doesn't differentiate the densities of the residential covers that it maps. So I've tried to incorporate that in a simpler way that I could do in a short amount of time. So I'll show you how I've done that, because that's important for modeling the hydrology as well. So yeah, so of the 73 national land cover classes, there are 54 present in the catchments that we're working with. And there are 37 of which of those have significant coverage. That's still quite a lot in terms of the number of HRUs and the speed of the model run, et cetera, and just being able to parameterize them. So I reclassed this into 20 classes, which is still quite a few. But I thought these are ones we'd want to keep as separate. So these are the 20 classes. These names, these abbreviations are, and crop, we call it crop names, even though they're not crops. The history of the SWAT model, it started in an agricultural setting. So some of the, inputs and tables and things like that say crop, even when it's like a residential land cover instead of land cover name, just from the history of that. So, but these names and these codes are cover classes that already exist in the SWAT's internal database. We can create new cover classes in the database if you want, but then you have to set up all the various parameters that are needed. And so the strategy that I often take when I'm doing this is finding the closest one that already exists in SWAT's database and matching that to the classes that I want. And then I can modify the parameters starting with the ones that are already in SWAT as a start, because those parameters have been tested for these kinds of vegetation types in other settings and been found to work well. So using that as a starting base and then modifying from there. So I'll get into what some of these very general ones, like agricultural land generic, obviously that doesn't tell you much, or row crops or close grown doesn't tell you much about what it is. So I'll show you how it links to the national land cover classification. So just a screenshot of the national land cover map for our area, the subcatchments in outlines in black, and you can pick up where some of the dams are to get a feel of where you're looking at. The red is plantation forest, and sugarcane is also in red. This coloring is the standard color map that the National Land Cover dataset comes with. And in my reclassification, I lumped most of the natural vegetation classes into broad structural categories. So like forest, denser woodland, open woodland, grassland, wetland. And then, as I mentioned, invasive alien vegetation is not in there. But pine plantations are in the mapping. The National Land Cover map also doesn't differentiate. They differentiate commercial forestry, but they don't differentiate eucalyptus versus pine versus other types. So I've that could be added at a later phase if there is mapping of that you would want to use. From a water quality perspective, I'm not sure it makes a huge difference. It could refine the hydrology a little bit in terms of the water use differences between eucalyptus and pine. But for now, it will just, I'm running the base model as calling them all pine. And then 4 different levels of residential area density that I try to differentiate, and I'll show you what those are. A limitation as well is that pasture land is not differentiated from other grasslands in the National Land Cover dataset. So if there is, from a hydrology point of view, pasture and grassland wouldn't be so extremely different if the pasture is not irrigated. But from a water quality point of view, it could make a difference in terms of if we want to apply, like, assume that manure is being applied on the pasture or any fertilizer that could wash off. And we can add those additions onto specific areas in the model, like the grassland area in a certain subcatchment could be assumed to have a manure application on it. So that can still be added if we have information on that in the model the way it is now, even though it's not called pasture, it's all called grassland. If we know that this particular area, we can assign some inputs there. And then the cropland types that are included in the model set up as it is now are sugarcane orchard. That's mapped by the National Land Cover. I assumed based on the region that it's primarily oranges or nut trees, or a mix of those. And then commercial irrigated crops. So these I assumed were vegetables, and I used some parameters based on information on cabbage farming, actually, as a common one. And then commercial dryland agriculture as assumed to be maize, and subsistence dryland agriculture also assumed to be maize in terms of parameterizing those cover types. So a map of those 20 cover types here is shown here. So this is what I prepared to do the SWAT model input. And SWAT requires the land cover to be input as a raster file where all the grid cells have a number. So numbered 1 through 20, and then there's a text file linking those numbers to the cover codes, these 4-letter codes that correspond, that corresponds to the SWAT plant properties database. And we went through that a bit in the tutorial for the robot model, where there was a land cover map, and then there was a text file that linked the land cover numbers with the codes and the database. And I'll show you that in SWAT again as well. And these tables just show you which of the National Land Cover map classes were lumped into these different SWAT cover classes. So, like, for example, FR FRSE, forest or forest evergreen, that was national land cover contiguous, assumed to be indigenous forest. Then there was low forest and thicket and dense woodland. I linked that to forest mixed in SWAT, which has a bit of a lower density than forest evergreen and SWAT also, but we can modify. It doesn't mean that we're assuming what forest evergreen and SWAT is. We want to keep as the indigenous forest, but it's a separate class that could be a good starting point. And then wetlands non-forested, you can see what that includes. Range grassland, everything that's mapped as grassland by the National Land Cover map. As I mentioned, you could zoom in and see that some might be actually pasture. Then there's this range brush, which includes fallow land and old fields and then open woodlands, because looking at those, some of these classes you can see are quite similar when you start looking into turning the aerial photography on and lumping those. There's very little cover of this fallow class there. My agricultural land generic is the commercial rain-fed crops, dryland crops, so non-irrigated. And then my row crops are subsistence annual crops, and then close grown. Row crops just means it's SWAT will assume that the vegetation is a bit more spread out. The leaf area index is lower. There's exposed soil between, which is what I would assume a bit for subsistence maize, for example. And then close grown is where it's a bit denser. So I assigned that for the pivot and non-pivot but irrigated crops. And then the orchards are all one. Sugarcane, the National Land Cover map does differentiate irrigated and non-irrigated. However, there was very, very little area that was mapped as irrigated within the catchment, so I did lump those. Pines I'll come back to. I lumped dense plantation forest and open, what's mapped as open, and I'll tell you about why. These barren types. And then urban recreational areas. You can see there's tree, bush, grass, and bear in here as mapped, but there's mostly grass when you zoom in on it, and there's very little of the other classes, so I did lump them. The tree and bush areas tend to be just borders around parks and golf courses, so it is mostly grass. So I linked that to Bermuda grass as a type in SWAT that could represent that. And then where it does get more complicated and more important to think about for us as well. So the crop types are important to think about, and then in our context, especially with the land water quality being the goal, or one of the goals, as well as the hydrology. We also want to think about the urban and residential classes and how these are represented in the model and what parameters we assign to them. So in the model, there are these, SWAT gives you these 4 residential types, as well as a commercial and industrial type in its suggested database. And each one of those has SWAT assumes impervious area densities of different levels in increasing amounts. And I'll go into the database and show you those. And so I looked at the National Land Cover map and I assigned, what I did was look at some of the aerial photography, like the Google Earth background image for these different, what was mapped as these different classes, and tried to lump ones that looked similar, but that was a bit tricky to do in some of these other ones. So residential formal, what was mapped as residential formal really varied a lot in its density of buildings. And I'll show you this now. It was quite low density in a lot of the area, but within Sunduzi, uMngeni, Ubulwezi, and Umdoni municipalities, you could see, near cities, what was mapped as the same class as elsewhere was really a lot denser in terms of buildings. What I also noticed was areas that were mapped as residential with trees, even when they were in around towns, that area tended to be very low density, no matter where it was mapped. So I put it in this low density class. So I'm going to jump into GIS and show you that. So I just did a simple, reclassification that if these residential formal areas were found in these municipalities, they were assigned to the high density class, whereas they were mid to low density elsewhere. And then I found similarly, when something was mapped as village scattered or dense, it tended to be at the edges. If it was in these municipalities, it tended to be at the edges of these higher density areas, and it was denser than when it was mapped elsewhere in our area. So I think it's useful to look at that quickly in GIS, just to show you what I mean and why I reclassed them. Yeah, this is just, showing hardly any. So yeah, this one, hardly any buildings were mapped in that class. Also, oh yes, also I wanted to note that I've kept classes that the National Land Cover Mapping labeled as informal, as separate. We could apply some different water quality parameters to those areas if we have an idea of what it is to apply. I'm not confident that their mapping of informal versus formal, it's done using rules based on the remote sensing, I think, for the whole country. So it might, get those kinds of classes wrong in different places. There were places that looked quite formal that were mapped as informal here. But as a starting point, we can use it. Then there's a wide variety of impervious surfaces within a given class. That's what I mentioned. So I broke them up by using these municipal boundaries. So let me jump into GIS briefly to show you that. And show sec and new projects. Okay. Oops. And down there. Okay. Are you seeing my GIS projects here? So, right. So if I turn on some of the municipality boundaries, and here. And find, oh yeah, it's gonna help with the built up areas. Yeah. So what you can see a bit is that these areas are this residential formal, mostly this low veg, and some are the bush and tree. So a lot of the treed area, the class that's mapped as residential formal tree, seem to a lot of be these riparian boundaries. And it catches a few buildings, obviously, because it's mapping at a grid cell square, but I made that class into a low density. And then the formal bush and formal low veg grass and formal bare are mapped as a higher density. I put them in a higher density class for the model purposes. But this is that same class, and now some area like this is mapped as, I think, village. Yeah, this is some of the village map, and the density is not so different. It is a bit lower than what's mapped as formal. but it's not such a different density. So if you think about that area within Msunduzi municipality, if I look at what this area, this pink color that's a residential formal, and I go somewhere else, like in the catchment of Hazelmere, for example, even I'm leaving my catchments on. Okay. Oh yeah, there we go. Okay. If I go somewhere over here, you'll see areas that were mapped to that same class that are really not very dense at all. So I didn't want, so that's why the same class that is mapped by the National Land Cover data set, I can put it into quite different types in our model classification, because if you look at the density of that compared to what we just looked at in the Msunduzi, it's very different. And if I were to go, let me open the SWAT editor for a moment. Model. Let's see, I think it's database is urban. Here we go. Okay, so these urban classes I mentioned, there's a fraction impervious assigned to each one. So there is, do we have, okay. Low density is about 12%. So these are the defaults in SWAT, and then we can change them from there. So residential high density is 0.6, residential low density is 0.12, then there's mid, and mid to low 0.2. I guess it's alphabetized rather than, I can sort it by impervious. There we go. That's better. Yeah, so there's industrial is assumed to be 84% impervious, commercial 0.6, high density residential, institutional, I guess that is. I didn't use that class, but medium density, mid to low density, and low density. And then another important parameter for urban or residential areas is the connected impervious. So that's the fraction of this impervious area that we think is directly connected to the stream, like or directly connected, I guess, yeah, to the drainage network through storm drains, for example, rather than there's an impervious surface, but it could then be run into a yard, a grassy yard, or another buffer strip or something. And those are things, this would be a way something to keep in mind for like a scenarios approach one could use. You could change these values, like you can't necessarily always change how much impervious area. You can prevent it from getting more impervious, but it's hard to make something become less impervious. But what one can do is, provide more buffers or green areas to catch some of the stormwater in between things. And you would represent that by changing how connected the impervious area is to the stream. And then these are some of the loading or like ways that impervious area can contribute to nitrogen and phosphorus. Yeah, there's total nitrogen, there's also nitrates. And these are default values assuming different kinds of areas and atmospheric deposition, etc. We can add things like increase it if we think that it's a way of representing sort of diffuse non-point source pollution on these urban and residential areas. We could change things like that. on these, or we can represent that as a point source, which I'll come back to. It depends how much we think it's dependent on how much it rains on these areas, what washes off of them, versus like a pipe leak, which is not going to happen, or like a sewer system leak, sorry, sewage rather than not stormwater sewage, but like when it depends how much we want to link it to the rainfall versus something that could be leaking at any time, regardless of the rainfall, for other reasons. So sanitation issues that are happening regardless of whether or not it rains, or if we want it linked to the rain, it can be something that washes off the surface, which we could consider here, but here it just gives you options for nitrogen and phosphorus, and it's septic, which we could use as a way to also represent flow of nitrogen and phosphorus off of these areas, if you know that to be an issue, like we could assume some informal sanitation that could be represented as a very leaky septic system in the model, for example. So that's something to consider as a way of representing things in these areas, these residential areas. So in addition to those, so for these, to come back to setting up the land cover types in the model, there are the hydrological parameters that I mentioned for just getting the flow off the landscape right. So the curve number, present and pervious area, leaf area index, root depth, and then how the roots can access the subsurface water within that depth that I mentioned before. So those, I've been changing them a bit from the initial based on ACRU database. In the name of time, I'm not going to go through all the changes for each type, but I'll provide that. But some and other ones to consider. So I will talk now through some of the plantation, what I would assume for the plantations and the agricultural types. But before I do that, was what I showed about the residential classes that I'm including in the model. Is that clear to people? What I've done there. Does anybody have any questions about how that's been mapped and input? Because that is something that you can consider how to change or improve going forward to better represent what it is you want to explore with the model. Okay, sounds like that made some sense. But yeah, if you have ideas about that or ways that you think we can change it or things you want to represent, or you want me to, I can also show you anything in the GIS. I'll share the files soon. I'm just cleaning them up still as I improve some things. And then you can look through them directly yourself as well. Okay, so I'll go on from the residential part. So there is quite a fair bit of pine or forestry in the region, as you know. And the National Land Cover Dataset maps things. It's mapped based on aerial photography at the time, but not aerial photography, pardon me, satellite imagery taken from certain dates. So at any given time, some of the forestry area is going to be at different ages of trees, and some of it's going to have been harvested and be open. To make the modeling simple, like over time, the areas that are harvested and the areas of different ages are obviously going to change spatially and over time, and that's quite tricky to represent directly in the model. So what I've done to keep it simple at this point is just called all the plantation area plantation or forestry plantation pine in this case, and assumed that it's all got an even set of properties over the whole area, and just assume that those properties are for like a mid-age plantation, because some of it's going to be young and some of it's going to be old and some of it's going to be harvested and not recently. And it's hard to consider that individually. That may mean that some of the performance is a little bit hindered, because in reality, you could have a subcatchment where it all just got harvested this year, and then another subcatchment area where it's all old plantation and stuff. So if that does happen, it's just sort of beyond the capacity to represent that directly at this point. So it's just assumed to be all sort of mid-age plantation. Now, for the crop types, that's where there's more probably water quality input considerations. Sugarcane, I've assumed it's all not irrigated but is fertilized. Orchards, I've assumed it's irrigated and fertilized. Commercial, as I mentioned before, I was assuming it's cabbage mostly, but I'm assuming it's a mix of vegetables, but I'm using parameters based somewhat on cabbage. And then information on Department of Agriculture and others on suggested applications for those, and in suggested applications for KZN where I could find them. But I don't know if that's what people are actually doing. And then similarly for maize, not irrigated and fertilized for what was mapped as commercial dryland. And then subsistence dryland, assuming it's maize, not irrigated, and then less fertilized than commercial dryland. So what the model needs for these different types is either specified times and amounts of irrigation, or triggers within certain seasons, and then where the water is being drawn from for different irrigated areas. So the easiest is to say that it's drawn from the stream in the same subcatchment that it is in, but you could also draw it from groundwater if people, or sorry, that's also simple. But you can also draw it from specific reservoirs, which is a bit more complicated to set up. There's not a huge amount of irrigation comparatively, so I think getting it right is not, we want to get it as right as we can, but I think more the fertilizer application is a bit more important to represent here, but I may be wrong about that. People, you can correct me there. So what I said for the irrigation is that within the growing season of whichever crop it is, irrigation would occur if the soil drops below, I think the suggested is like, I think below 0.8%, or 80% of field capacity, to then apply irrigation water up to a maximum flow rate. So from the center pivots, and then, or with center pivots for the low crops, and then sprays for the orchards. And then but the fertilizers, you also have to specify when it's applied and how much is applied, and then the nitrogen and what type of fertilizer it is, the nitrogen and phosphorus content of the fertilizer. So we open up a table to show you a bit like what that looked like. So like for commercial, so for example, for commercial crops for maize, and then assuming, oh yes, I also assumed that there was maize in the summer and then alternated with veggies grown in the winter on areas that was mapped as commercial crop and rain fed. I found some guidance from KZN Rural Development Department, from SIDARA, and ARC, Agricultural Research Council, on maize, for example, and there sort of be different suggestions on how many tons per hectare of fertilizer with, and how many the nitrogen and phosphorus contents, and when, sorry, I probably can't read that. Let me zoom in a bit. when to apply fertilizers at different times, when to plant, etc. Because we had to tell the model when that's happening for the crop types. And some of this is important for the nitrogen and phosphorus we're assuming is going to wash off of the landscape into the rivers for the agricultural areas. And so I looked across these different sources and I made some assumptions on timing of planting and tilling, and then kilogram, like you have to set up a fertilizer type that has a name in the model. So like P could just be pure phosphorus. LAN is a fertilizer type that I found in the literature was recommended for use in South Africa for these cases. Trying to remember I have what it stands for somewhere. But then I have, kilograms per hectare being applied at planting, and then the fraction, the fraction of the application on the surface versus being worked in. And then ended up spreading it out because if you put it in, I didn't want all, every maize HRU in the whole model to be assumed to have fertilizer applied to it on the exact same day, because that wouldn't be how it's actually happening. Not every farmer is going to apply on the same day as one another. So then I worked out what it would look like if that was the case, but then I spread out the application over time, because I don't know exactly when different people are putting fertilizer on. So I spread out the days, just assuming like lower application rates. A farmer may put all of it on in one day in reality, but over the entire landscape, if each farmer is putting it on a slightly different day, I've just sort of spread the amount over a longer period of days, evenly over the landscape, all the maize areas as a whole, so that it's not like one day that everything is applied. So I did an even spread of the kilograms, being applied between, 10th of October and the 30th of November, for example. Instead of saying everything's applied on the 10th of October. And so forth. And then you can trigger it also. So I did, and similarly for cabbage and similarly for maize. So I need to, pardon me, I should update my presentation just to show that I did assume that the commercial non-irrigated wasn't all maize. It was maize in the summer and vegetables in the winter. And the fertilizer, yeah, limestone, that LAN is limestone ammonium nitrate. And these are some of the other fertilizers. So in the model, one would set up a fertilizer type and set up the schedule of application. And this is something I will send more details on, because I had this worked out fairly well in the original SWAT, and the new SWAT has a new format for inputting these things in what's called the decision table. And it's not doing exactly what I thought it would, and I'm having some back and forth with one of the model developers to help me fix that. So I don't want to give that part to you at the moment. I'll try and have it fixed by next week, ideally, because it's not doing what it did in the previous model, and I think there's an input that I have wrong. So I will fix that to be similar to what we had before. But if anyone has particular details on fertilizer application and crop types across the modeled area, do let me know. And then I could make it more locally tailored. So yeah, for now, the fertilizer is I worked out the amounts that one might apply in 2 separate doses as in the guidance, but then I spread that out over time to represent a bigger landscape rather than an individual farm. Yes, Amani.
Oh, hey, Julia, I had a question. Does SWAT tailor to crop modeling, as in crop parameters that's important? Because what you have just now is an overview of you've shown an overview how you will rotate between winter and summer crops, between cabbages and maize. And what I've observed is most of the time the maize in the uMngeni catchment, usually it's for animal feeding. Then they rotate it with wheat in winter. Then
Okay.
you rarely get maize. So if SWAT is sensitive to crop parameters that may be of important or not, I'm just asking.
Yeah. So do you think it would be better to do maize in the summer and wheat in the winter?
Yes, in the summer
Or
fields, because you can scale wheat as much as maize, but it is rarely the case for cabbages.
okay, so it's more often wheat in the winter. Yeah, no, it is. So there are these you can input parameters and like there's parameters for cabbage in the model that they have an idea of and there's parameters for wheat, and you can tell it when different ones are grown, and then you can tell it when fertilizers are applied. It doesn't know, you have to tell it what fertilizer is applied and when. If I say that it's cabbages, it won't assign fertilizers without me telling. I have to find out what people apply generally to wheat or to cabbage or to maize and tell it that. It has a bunch of like standard fertilizer types that are common in the United States per se. So I had to look at what's commonly applied or recommended by Department of Agriculture and others in South Africa. So like 5-10, like this 5-10-10 is a proportion of phosphorus and nitrogen and potassium in the fertilizer. That is I guess, a product ratio that you would find in the United States commonly. Some of them will be, or Europe, like other places, but I don't. These names of fertilizers that it has, but I can create a new type of fertilizer and give it my own name in the database. And I can create a fertilizer name like LAN. And then, which is one that I found in the literature, for example. Where's my spreadsheet? And tell it when to apply. So what was limestone ammonium nitrates, which is 28% nitrogen, 14% of which sorry, not of which, but in total it's 14% ammonia and 14% nitrates. It doesn't have phosphorus and potassium in it. Or you can have like 234 is a fertilizer type that's has this many percent. So the 234 refers to something and other ratios than the total nitrogen, I think. Yeah. It's a different way of working out the ratios than what SWAT does. And then you can give that a name, or superphosphates as a product. And then you can give it the percentages, and then see some of these were other ones that I found. And then you can set up that fertilizer in the model, how fraction of the fertilizer that's mineral nitrogen, mineral phosphate, organic nitrogen, organic phosphate, and then fraction of the mineral phosphate that is ammonia. And then you can set that up, and then you can say when it's applied to your crop in a decision table. Management with, so there's irrigation, these are demonstration irrigation ones, there's the fertilizer ones. So you can trigger fertilization on specific time periods, or you can trigger fertilization when the plants reach a certain stress level, which we could also do. I'm just not sure if that's the way that farmers are doing, if they watch and they apply when it reaches a stress level, or if they just apply at a certain time of year regardless. So these are things, so one thing I will take from today is that I should replace the winter crop for wheat on that non-commercial, or sorry, non-irrigated commercial area. So that was really helpful. If there's other, is that making sense, Amani? Sorry, am I answering your question about how crops are considered here?
Yes, if I get you, you are saying if you are changing a crop, then if you're introducing a crop, then you have to introduce an application regime for that crop.
Yes, yeah. And you can, like, for a specific area, so I have a map. I have a map of my land cover types that I've input, and it's made the HRUs based on the land cover types. So for each land cover type in my map, if it's a crop type, I can say this land cover type is a crop. People grow, and then I can give it a sequence over the year. I can say over these months it's maize, and over these months that same area can be wheat. Over the course of a year, it's irrigated in this way, and over the course of a year, it's fertilized in this way. And so the crops can switch on a given area over the course of a year. So I sort of give it the annual cycle of what's there. So I have to come up, so in our model, we can come up with an annual cycle for what's on commercial irrigate. So the types that have been mapped individually are commercial irrigated, commercial dryland, and subsistence dryland. So if you have the way I've set it up at the moment, which I can still change based on your input, is what is actually on the ground in commercial irrigated. So I assumed, in commercial dryland and commercial and subsistence dryland. So for commercial irrigated, I assumed that it was vegetables, but that may not be the case. And then in dryland, so if I go to, let's just go to some of the places that actually have that cover, for example. So if there is this type, so let me find some of it in our area. So I just want to see where the bulk of it is. So we can highlight it and go check. Because I think this is important for how the model is set up. So I wanted your having your input here is very helpful. So commercial is what number? Let's check here. Okay, so the close ground, the commercial irrigated was 8. Subsistence is 7. Okay, commercial dryland is 6. So I go to 8, for example. Let's turn off that. Okay, so it's turned bright blue. I've highlighted 8, which is the commercial irrigated. I just want to show you some of the areas that's that class. And if you happen to know, is there a particular part of the map I should zoom in on? like above. Seeing most of this kind over here. Like if we're going above the catchment of Midmar, for example, or even over here by Spring Grove. What are we seeing there? These. See, like I don't know what's happening on these pivots. Do you have, what are people typically growing on these pivots that you've seen? Would that be maize in the summer and wheat in the winter?
Yes.
Okay. Those are ones that are mapped commercial. Great, so I'll change that. That should commercial irrigated. So for those center pivots. I just highlight it. And then commercial dryland, I'll show you some of the areas that have been mapped as that. That was class 7. That was class 6, actually. Let's check. Yeah, class 6. Okay, so if I highlight class 6, there's less. Huh. Oh, sorry. This one. Yeah, okay. So it's often land, so it's turned this bright blue color. It's often like the land that's right near the center pivots. So if I turn off the land cover map, and I'll show you the aerial photography, because I could assume that it's the same. Yeah, some of it even is mismapping pivots. Oh yeah. So okay, so some of it actually has some pivots on it. If you see when I turn it on and off, I hope are you guys able to see my screen all right? So if I turn it's the areas that are bright blue because I've selected it in the GIS, and then I turn it off. Some of it even has old center pivots on it, even though it wasn't mapped by the National Land Cover Map as center pivot. So some of it may actually be irrigated. It's just not mapped as irrigated. Unfortunately, yeah, there is some error in these maps. They generally get the big classes right, but the distinction between irrigated and not irrigated, they don't. That's the other thing, is that it changes over time what people are irrigating, and whether or not it looked green enough. They look at how green things stay over time, and if it stays very green over time, they assume it's irrigated. But sometimes people don't irrigate some years and they irrigate other years. Okay. Because I could assume that all of this is also maize and wheat. Let me zoom out. It seems to be mostly the boundary areas around the stuff that's mapped as the center pivots. If we go up above like Mearns and Spring Grove, like these areas, would you guys agree that it's similar agriculture out here? Mostly maize and wheat. Does anybody have ideas there? Zamani, if
Sorry, Julia. Can you hear me?
yes, yeah, I can hear you now.
So we're having a small discussion here. We also thinking that some of the areas upstream of Midma may be irrigated pasture. Maybe I'm not sure if you've mapped that in some of your classification.
So you see, on the classification, I've used the National Land Cover map, and so I reclassed the types that it has, and it does not, unfortunately, it doesn't map pasture specifically. The classes it maps are the types that I showed. So I've kept most of those from the agricultural standpoint. So it maps, and it can get things wrong. So I haven't mapped things myself. I've used the National Land Cover map from 2022, which is done at a national scale. So it does get things wrong a bit. It can do. So it has commercial annual pivot irrigated, commercial annual non-pivot irrigated, commercial annual rain-fed or like non-irrigated dryland, and then subsistence. And then sugarcane is mapped differently. So I haven't mapped anything myself here. I'm using the National Land Cover map classes, but as you can see, they're quite simple. And like, I think they got some of the irrigated, non-irrigated incorrect, but I don't have the capacity at this point to like remap everything. That would be a whole other project. But if you have any existing maps, that you would rather that I use, I can do that. Or I've just had to make assumptions about what these classes are, because like that, it doesn't tell me. So just by doing like very brief literature looking what people are growing in that area, but you guys are on the ground and I didn't find great reports. So maybe I didn't look in the right places, but if you have a better idea of what some of these are, or where I should look to find out what some of them are. So I'm showing you the assumptions I made about what these are. So I was assuming vegetables, maize. I hadn't assumed winter wheat. So if I could assume pasture also, if you think it's more likely that most of this is pasture. And then it's lumped, this class is mapped over the whole area. So it's pivot irrigated over the whole area. I think, so it doesn't sort of differentiate. It's like pivot irrigated would be one class, or irrigated and non-irrigated would be one class over the whole of our modeled area. I could make subclasses within different like regions or municipalities or the catchments of different dams and assume that those are different. I can do that quite easily if we have an idea of what they are. I could say like all the area that's mapped as irrigated above Midmar is pasture, and all the land that's mapped as irrigated like around Spring Grove is wheat, or for example, if we had a set of assumptions we wanted to make. The differences that where it's going to come out, where it's going to be reasonable to try and differentiate things in our results is if we think it's mostly about deciding what the fertilizer application should be in the model. I don't know enough about wheat, wheat fertilizer versus cabbage fertilizer versus maize off the top of my head to know whether it's going to be a big difference or a small difference. I can't tell you that on the call right now, but I can look into how big of a difference it might make. If the fertilizer applications are fairly similar across the crops, then it doesn't matter hugely for our model output. But if they're fertilized quite differently, then it will matter for what we're predicting is going to be the input, the outputs into the streams. Does that make sense? So what I can do, like, and I also don't know if pasture. So I'll do a little looking if we think that pasture versus wheat versus maize has quite different. I think pasture might be fertilized in quite a different way than the crops. But we're gonna have to assume that it's a mix of those things. If we don't know, like, where exactly it's one versus another. But if any of you have, so what I'll do based on this conversation, I think this is super helpful. This is exactly what I wanted to interact with you about as well, so that you know what's in there and we can talk about what to assume or not assume, and then how to improve it going forward, because these models you can yeah, it's never perfect. So you just have to get to a point where it's useful, and then you can see how to improve it over time as we go. I've used the National Land Cover Map because it's going to be, they're going to keep remaking it, every 2 years using the same methodology. So it's something you can look at how things are changing, and update the model more easily by using a standard map. But if there are better maps that you have in terms of where crops are, we can combine them, and make a map that we use for the model that has the crops specified. I just didn't have that easily accessible that I knew about. So yeah, so we can come and improve it. I think for now, if you have any more information that you want me to put in the short term, what I can also do is look into maize versus pasture versus wheat fertilizing practices. And I can try and make something that gets applied in the model that's a mix, like a blend of those, assuming there's a bit of each in the landscape. If you have anything else more specific than that, I can also see how to include it. Do you have any, is there anything that you know about right now that you want to tell me about how I should do it differently than that in the short term?
From me, I think it's just an idea of some sort. Maybe if you could look into land suitability maps, because here in KZN, along the coast, you have your sugarcane and whatnot. Then as you go up to the Drankensberg, then your suitability changes based on the temperatures and everything. So maybe we can, for each elevation yes, for each elevation along your catchment, and you can try to assume that you have these crops rotating and so on, starting interchanging based on the elevation. I don't know if you get me.
Yeah. So fortunately, sugarcane, at least sugarcane has been mapped. So sugarcane is the purple. And so sugarcane will get its own properties in the model. So the National Land Cover Map they were able to map sugarcane. So sugarcane's there as its own thing. But I do get you to look into where it might be wheat, where and when it might be wheat versus something else in these other parts. So the oranges are the other agriculture. The dark red is the pines. The different shades of orange are the different kinds of agriculture in the National Land Cover Map, either irrigated, not irrigated, commercial, or subsistence. So for irrigation that's considered subsistence, so non-commercial, what I assumed there was also maize in the summer. And then I think, do people often do you have a sense of what people grow subsistence wise? Just in general across the year, would it be maize? Would it be 2 rounds of maize, or would they do vegetables in the winter? I'm assuming it would be I mean, it's always going to be a mix across people and areas. And we can't represent everything in infinite detail, but just a broad idea of what people do across the year.
Yes, I think subsistently, yeah, that's what happens. You have maize in the summer, then crops, vegetable crops in winter.
The winter. Okay. So I'll keep it like that for the subsistence one, maize and then I'll look into what it might be for the commercial in terms of wheat and pasture as well, versus not just maize, for those pivots, and try and see if I can do an elevation divide perhaps, because that's a good, or a suitability map. Right, no, that's helpful. Let's see. So, and similarly for right. So I think what I want to yeah, so I wanted to make sure everybody has an idea that, yeah, there are these types, and I've had to make assumptions about them. We have to make assumptions about them in the model. And then for each type that we're able to map, it will have an irrigation and fertilizer schedule that we input. I think for our purposes, the fertilizer schedule might be the most important thing in terms of trying to look at how it impacts the water quality. Irrigation maybe, I guess part of why the irrigation may matter is that if the land is already quite wet from being irrigated and then a storm comes through, you end up having more surface runoff that can carry the fertilizers away, than if the land was quite dry the day before the rain comes. If the soil is quite saturated and then it rains on top of that, then you're likely to have more wash through and wash off of the fertilizers that have been applied. So I will try and get the irrigation right, but I do want to try and get the fertilizer application to be somewhat reasonable to what is being done in the region so that we can get an idea of the non-point source from fertilizers. And that'll always be tied to, how much is mapped of what kind of crops and where it is, how close to the stream in the model. Then the next, I was going to move on to soils a bit, but I think this land cover discussion is actually it's one of the things we can change we can find the most information about to change and try and represent, because those would be the scenarios that you would change. So I do want to spend some time on it. Yeah, primarily I want to spend time with you guys today on the land cover as we've been doing. And then the other one is how we input point sources into the model and what I've input so far and what else you think I should input to try and represent the water quality inputs in the model. I'm just looking at the time. I could introduce the soils briefly now, or we could take a break and then come back and do the soils, like the next steps, the soils, the aquifers, the reservoirs, and the point sources, with most time on the point sources. People want to does anybody have any other inputs on the land cover? And then I think let's take a break after that. People have questions or inputs on land cover, and how it's being input and represented in the model. If things come up later, if anybody is trying to talk, you're muted. But if you think of things later, please do come back to me as some of the ideas, as you discuss them more. Okay, so let's see, it's almost 3. Let's break until 3:10. Stretch, get a cup of tea, and then we'll come back and we'll talk about the next parts. That work well for everyone? I know it's hard to be online for so long. So I'm just going to pause for a minute. Back. Put it in the chat for anyone who's in and out. Hi, everyone. Are people back? I'll just pause a moment until people are back in the room. Oh, and Tando's okay, you're back. I'll go on. Okay, great. I'm seeing a few thumbs up. I'll go on. So I just did an overview of what the land cover inputs, have been used to set up the model. The next inputs for generating the HRUs and calculating the processes are the soils, and they're quite important in SWAT, actually in most hydrological modeling. The first time I set up the model in the older version of SWAT, I used a soils map and a soils properties database that was based on the Agricultural Research Council land types mapping. And the ARC land types mapping and soils database was converted into a SWAT formatted database by the University of the Free States as part of a Water Research Commission project. They took what's in the ARC database and they just modified the formatting of it to have the SWAT format and the parameters that SWAT needs for soils. So things like depth, percentage of clay, field capacity, saturation, those things in the format that SWAT needs. And I used that as it stands in the first round. But what I found was it includes too many, the parameters didn't work that well. The model didn't behave that well, and I needed to adjust the soils quite a bit to get a good stream flow and from it. And when you have so many different soil types and you have to adjust them, I had to make different adjustments to different types because different areas of the landscape were having different types of errors. So it wasn't like everywhere was having too much base flow. It was like some places were having too much base flow and some places were having too little. So I had to make different adjustments to the soils in different places. And what I found was it was quite difficult to do that with, there were 74 classes of soils in the modeled area in that first round of the model. And it became very difficult and very time consuming and difficult to make the adjustments that we needed. And there actually just isn't as much information on the soils locally as that in any case. So I've made a simpler version that's still fairly complicated spatially, I'll show you, that has fewer classes. It ends up with 19 types. But it still represents the variability over the area to make adjustments to some of the soil's properties. And I use the actual properties still based from the ARC database, but with some more averaging. So what I did was I used slopes and other landform mapping information to make a slope and position landform class map with 5 different classes. I used SWAT's mapping of floodplain areas along the river lines, and based on the way that the landscape accumulates and is flat around, they're wider where it's flatter around the river and then narrower where it's steeper around the rivers for a floodplain mapping. And then the lowland area where the land slope was low, but it's not right at the floodplain. And then a mid-slope area, which has a higher slope, and then very steep sloped areas, which I assume to have very thin soils. And you can see that in the aerial photography. It'll look like cliffs or exposed rock and stuff when the slopes are high, using the DEM. And then also upland areas that are flat, so upland plateaus. And so I did a slope type map, and I also overlaid that with the geology mapping of sandstones and granites and shales because those different landscape areas would have different soil types on different, if you've got shales and you see in the shale areas, it's more rolling topography.
So,
and then,
Julie,
hi, yes.
yes, are you projecting something?
Oh, is it not showing? Oh, apologies.
Yeah,
Sorry. Sorry for that. I started the recording. I didn't start the sharing. Apologies. So let me say, sorry. So just what I was going through there, yes, what's that? The ARC land types had 74 classes, which was too. It was difficult from a modeling point of view. It may be, yeah. And I think actually when you look at it, mapping some of these land forms locally, and I'll show you a map of that in the GIS as well, is a bit more refined than the land types anyway, even though I have fewer different total classes at the end. And so then the properties for the soil types that I ended up with still came from that ARC-based database, using the average of which ARC types fell into my 19 types, but also giving extra weighting to the most frequently occurring type in my types. The reason, because sometimes it's that there's a mismapping of where they thought a high slope area is versus where I actually mapped a high slope area, for example. So sometimes I can't expect them to line up exactly. So types that occurred very infrequently in my more coarse classes, I didn't want to give them as much weight because it might just be that they occurred there, they overlapped because of a mismapping, not because they really overlap. So the types that I came up with, I had to then make a grid of that and put that into the model, but I'll show you. So I used, let me just go to the geology map from the aquifer to show you. So I used the Geology Council of Geosciences, apparently, mapping of geology. So there's shale, basalt, tillite, different types of sandstone, different types of shales, and then granites and gneiss, dolerites, intrusions, which are harder rock. The Natal sandstones are the dominant ones that occur in our area. So you can see there. So I overlaid that with the slope groupings, which I should probably easier to, or the slope and the topographic position groupings, to make these combination soil types. So BST is for basalt, and then like 3, 4, 5, those are different landscape positions. DLT is dolerite, GNG is granite and gneiss. SDS is sandstone, shale and tillite, and then these 3, 4, the numbering has to do with what is it, a upper plateau, is it a slope, is it a lowland, or a floodplain on that geology. And then I used properties from that ARC soils database that occurred on those types. So it was a way of reducing the number of soils types, but using a bit more local mapping as well. I'll just show you what the topography types look like as well, because I'll give you these as shape files and as grids, because they might be useful for other purposes. So if I, oops, sorry, escape the show for a sec, I'll show you in GIS. This one's, yeah. So it was quite, what was nice was that you did see, like, on the shales, on the areas that are more shale, versus the areas that are more sandstone, it's quite obvious that the topography change, like there's more rolling hills in the shale areas and more steep cliff areas in the sandstone. So like the green is the green and blue are the lower slope areas, and the purples are the cliff, more like steep cliffs, and the beige color like upland plateaus. So if I zoom in, you can see like an upland and then a more riparian zone. And it's nice that you can see it on the ground as well, like these lowland areas that are greener, and you see these drainage lines and more wetlandy areas get captured in the slope mapping. And then you see areas that have, when you get down here into some of you'll see like the more steep areas and upper plateau areas there. That's where the geology changes, between sandstones and granites in this case. And so there'll be other geologic boundaries that you'll see them captured in the slopes, and then those different geologies would create different soils. So like sandstones will have more sandy soils and shales will have more clayey soils on them. And I get the properties of those from the ARC database, which takes that into account. So the resulting combined geology and like location class soils map that I made it's like this. So you can see there are some a bit odd boundaries sometimes because the geology mapping doesn't always line up perfectly with the slope mapping. And so I did do some cleaning up of that in the raster file in as much as I could, but some of it is going to remain a little uneven edges, unfortunately. But it would take a long time to fix every tiny little weird edge, but it does give you a fairly reasonable idea of how the soils would likely vary over the area. And so that gets input into the model as, again, as a grid, a raster file, a TIFF, that has the numbers for every grid cell, and then the numbers correspond. There's a table that shows which number corresponds with which soil type code. And then there's a soils database file that has properties for all the soils. And those properties can show you this one. Model. That's the lookup table. It ended up in, yes, okay, so that's just the table that matches the grids to the soil types. I'll find, it's actually in the modeling folder. Inputs my user soil, yeah. So like the soils database will have the maximum depth of the soil, and then by layer, it has bulk density, water holding capacity, conductivity, carbon, clay, silt, sand, rock, and then erodibility factor. And then it would start again from layer 2. So you can have as many layers as you'd like, but the ARC, the database that was made for SWAT from the ARC land types just assumes 2 soil types. I mean, 2 soil layers, apology. So the rest, if you wanted to divide it further into further layers within the same depth, we could do that if we had information to do it with. But it's just got 2 types for now. I think SWAT, you can have up to 12 different soil layers if you want to, if you have information about it. But if you don't have information, you leave those blank, and then you have, in this case, we just have 2. So like soil depth 2 for layer 2. and like soil depth for layer 1, bulk density for layer 1. So this database has to be prepared with numbers and names that match your map, and then you can input it into the model and it'll bring these properties into the model. And then once they're in the model, we can change them in the model without going back to our table necessarily, but the soils, so it'll show the various properties in different tables. Here, it's just showing those. Oh yeah, okay, and then the layers are here. So I can also modify them here once the model is set up within the SWAT Plus editor to try and get the performance, try and improve performance. So things that will create more, if you increase the available water holding capacity, this one, then more water will be kept in the soil for and allow more evapotranspiration to occur. And it would reduce the stream flow to some degree. If more of it is allowed to then flow downwards into the groundwater recharge, and then it could increase your groundwater outflow as well. So I'm modifying, you modify different elements of these parameters to try and get the base flow versus storm flow to match better what we're seeing on the ground within reason. You don't want to take these values outside of bounds that we think are physically reasonable, for example. So we'll talk about that more next time. But that's where the first starting values came from, what I just described using the ARC database, but using a different mapping of classes. Yeah, as I mentioned, it doesn't have, I don't think this will be as impactful. It's impactful for getting the hydrology right. But in terms of getting the water quality, we want to get the hydrology right so that the runoff, surface runoff versus subsurface runoff versus groundwater runoff contributions are reasonable. And that's where it comes in to the water quality part as well, because the surface runoff will carry more of the non-point source pollution to the streams. There's more filtering through the soils. The model does actually account for that. So these properties are important for that part. So it's sort of indirectly influencing the water quality outputs as well. Does anybody have any questions on the soils part? I'll move on, but we can always come back to things as needed. Then the aquifers are input. I used the geology map with the subcatchments overlaid on it. This one should have had I put the geology map. In SWAT, there's an upland and a lowland aquifer within each subcatchment. So I did I worked out there's only one aquifer within each subcatchment. Oh, sorry, two, the upland and the lowland. So I worked out the geology and the soil type. So the geology for the upland aquifer and then the soil type for the lowland aquifer for every subcatchment to input the parameters. And then we modify the starting parameters. So the sensitive ones, there are the level at which you start seeing outflow from the aquifer, and then the rate at which the aquifer outflows. So the fractured sandstones, just to give you an overview of that, the fractured sandstones generally hold most water. They have higher porosity or specific storage, I should say, for an aquifer, and then transmissivity as well. That's the rate of outflow is higher from the sandstones versus the shales, with the other ones sort of falling in between those two. So I used property parameters from the National Groundwater Assessment too, which also assigned some of these, it's estimated these properties at the quaternary catchment scale. So I use those to inform the first estimates, but then there's some calibration work beyond that, which we'll talk about next time. I don't want to spend too long on there because I want to spend some more time on the reservoirs and point sources. But if you have questions on the aquifers, I think it'll become clearer in the calibration discussion next time, but can... or the hydrology calibration parts at least. I'm going to move on to the reservoirs. So I've set up the model with 17 reservoirs as like explicit reservoirs, meaning that there's lots of areas that are mapped as open water areas that are farm dams, and SWAT Plus handles those a bit differently. So I didn't model them as, I didn't try and go through and get all the farm dams and model them as reservoirs, because SWAT Plus treats them like wetlands or ponds, the farm dams, which is a reasonable approach for that. So they store those areas in the land cover map that are mapped as water, and they aren't part of these big reservoirs that I've put in. They have a bit of water storage that overflows as well. So I don't need to do too much with that. They're treated essentially like wetlands. The farm dams, I'll show you that those areas that are mapped as that. Unless we find reason why we need to add them in as dams, specifically the other areas. But these are the ones I was given actually as I added a few for the ones I was given didn't include this Mackenzie Farm upper and lower and Itopo and Home Farm as separate ones. But when I went into the GIS and some of the aerial photography, these ones are quite large. So I'll show you what these ones are and then talk about what inputs I needed you need to set up the model for these as explicit reservoirs or water bodies in the model. So, oops, sorry to just jump out of the presentation for a sec. Where's my, I skipped, yeah. So when we look back at the land cover, there we go. When setting up the model, put in a shapefile for the reservoirs that you want to consider as reservoirs. And then any other areas that are mapped as water, like these guys, that are photography on. Yeah, okay. National Land Cover Map has this long tail. Get rid of that one. So there are lots of ponds and farm dams throughout the landscape, but to try and represent each one as individual reservoirs would be quite tricky, because you have to have the volume area relationships, etc. For each one, or you could lump it into one. That also gets quite complicated. But they're treated as water surface area stores that have runoff when they're over a certain point, depth of water on them. And then the main reservoirs that have a shape file, you can input as a shape file. That area actually gets cut out of the subcatchments so that it doesn't double count that area. So you can see the black lines are some subcatchment delineations. And so it has different branches, and then this version doesn't have that. Yeah, okay. But you can see like this outline, this land flows onto this branch of Midmar. So you could look at this area separately from this area flowing to this branch of Midmar, and then you have the land that's feeding the streams before you even get to the backflooded area of Midmar. So it's divided subcatchments up for different tributaries entering a reservoir. And then the reservoirs have a specified maximum storage volume and storage area, and then a volume area relationship that the model knows about that you input. So they'll receive water from all these contributing subcatchments and then fill up, and then you define the rules of how the water flows out once it's reached a certain volume. And I did quickly want to show you those other reservoirs that I added in case you know something more about them. Though one's by the home farm area. It was this sequence of reservoirs. The reason I added them was because I saw there's a wastewater treatment works and some withdrawals around this area. And these two dams, I think this one is called Home Farm and one's called the Ikopo Bucks in the information I was given, but these two dams just upstream look almost as large. They might not be as deep. But I thought getting the model right, it would be worth to consider them. So I used some of that I didn't have information about how much these can store in any of the databases, but I used that Sanzi data to estimate volume area relationships for these two. I'll show you, I think this GIS shows the one's too slow. Okay, if I turn that off. I've got this shape file is a bit too big, so it takes a long time to turn it off. There we go. Okay. If I go to that area I was talking about. Sorry, my GIS is being a bit slow today because I have my other projects were working fine. This one's quite delayed. While it's freezing and thinking, I'll mention the point sources and the streams. So this network we can see on the GIS screen. You can see these streams with numbers on them. And every time there's a different number, it's treating it as a different stream, and it can have its own point source addition to it. In addition to, the model will model the runoff from the surface and the soils and the groundwater and add it into the streams by land units. But we can add artificial inputs as point sources at any one of these points. We can give a time series of input water and what concentrations of nitrogen and phosphorus and sediment, etc., are in there. So I'll talk about how I have set that up next. I just briefly wanted to show you the reservoirs that I was having questions about. Yeah. And why they just seem that like these two are quite large. Does anybody work in this area in particular? We're near Gopo. I'm not sure the names of the towns around, but there's a Gopo Waterworks over there. And then I've seen this one labeled as home farm or Isidore. Do people know, anybody on the call know this area and this dam or set of dams well at all? I want to make sure I'm labeling it right when I give the data for these. Because there were different names. If anybody's trying to speak, they're muted. Okay. Not hearing anything from anyone on this one. Oh, Zamani, please just feel free to unmute yourself and talk.
I think Nwabisa, I think she's on call. She frequently visits this area, but the lowest dam is the home farm dam.
This one.
Yes.
Then okay.
The
I just wanted to use
the first one
this
is, I
one.
think it's Mackenzie. But
Okay.
she can
Yeah, I
confirm.
just saw in Google Maps, I saw Mackenzie Farm, so I just called this Mackenzie Upper and Mackenzie Lower, these two. But if there are other names you want me to use when I report on these ones, or like send data, the outputs on these ones, you can let me know. So I was calling this one Home Farm, and then this one, I think it was Ikopo Bucks.
Sorry, Julia.
Yes.
Yes, I want to confirm what Zamani was saying. So the dam that's the care sites in, or the bigger dam is farm. It's a farm dam. No, not it's census door. Census door. Then the upper one that is our dam, home farm dam. Then the upper one is the Mackenzie.
Okay. So this one I should call it Isidore. This one. Can you see
Census
my
door,
cursor?
just confirm the spelling.
ST Isador.
Oh, okay,
ST?
Saint Isidore.
STISADO.
Maybe I can just write the name on the chat.
Okay, great. Okay, so this one I should call it Saint Isidore. And then this one I call it Home Farm.
Home farm.
And that's the one, and this one is your dam.
Yes, we.
Okay, and then I think these two seem like they're part of the farms. I just call them Mackenzie Upper and Lower. Isidore. Okay, great. Yeah, I did see, thank you. Because I did see that name on some documents, and then I saw Home Farm, and there were just a few different names, and I wasn't sure which one should apply to which over here. They all have their own IDs in the model, so it's fine. It's just from a reporting point of view. So every reservoir then in the model out of the big ones, so these are the bigger ones, these 17 that they have a maximum storage capacity and surface area. The SWAT model calls this the emergency spillway. And then there's also another spillway level you can define. You can define the rules of when water flows out of the reservoirs to the downstream, or you can have an observed releases time series. When you do an observed releases time series, and that's what I've input for the dams where I had information from, there's a gauge or there's monitoring of, the outflow structure. And we have that for some of the dams from DWS and from UW. So where there was a time series of that, I specified it. For the other dams, so we have that for like Spring Grove and Mearns, Midmar, Albert Falls, Nagle, Henley. Actually, let me put the table up of which ones have outflow data for the reservoirs. Yeah, okay. So I've released time series for Nungwan, Hazelmere, Inanda, Nagle, Albert Falls, Midmar, Mearns, and Spring Grove. I have a time series of how much outflow there was from the dams for every day from either DWS or UW. For the other dams, the way that I've set them up is that once they fill, they spill. And so once they fill up to what the maximum storage capacity I found in the databases was. And so that gets input in the model for the reservoirs and this connections. And they just it has a reservoir number from the shape file. It wanted a number. I can go in. Actually, what I'll do, I'll go in and give these actual names. So I think I can do that without. Yeah, I think it'll keep the number 1 from the shape file, but I think if I give it a name, that'll help us when we're modifying things. I know the numbers from my table, but if I actually put it in the model interface, it'll help. So I'll do that. I'll double check that it doesn't. Oh, I wonder if I can do that. It links to some other tables. Okay, I'll check before I actually do that, but it's not gonna unlink things. Everything's linked in the model, so sometimes when you change things, it doesn't lose the links. But it has an area of the emergency, what they call the emergency spillway, and then a volume. And these are in hectares, and then it's a weird measure, but it's 10 to the power of 4 cubic meters. So it's not 1,000 and it's not 1,000,000, but they do that because it's the equivalent of a meter of water over a hectare of land, I think is what it is. But so I'll have a table of the capacities that I've used in easier, like I've gone from, it's 10 to the 4th cubic meters, and then areas in hectares. So I converted from the other units, and then you put it into the model. And then the ones where I didn't have a release time series, I assume that they just fill and then spill. So there's going to be some inaccuracies in that if there are releases that don't really follow that, or the model doesn't quite accurately predict when the dam is full. And so I'll show you that in the calibration. So we can't expect it to perform as well downstream of the dams where I've just had to assume a simple fill and spill versus using the observed releases. But there's not much more you can do than that if we don't have observed releases data. If at some point you have like rules that we should use about when releases happen compared to volume, other than just simple fill up and spill, those could be input in the model. It can handle different rules about, when it reaches this volume in this season, in these months of the year, release this much, etc. Can be input in these. You can have reservoir release decision tables, they call them. And you can specify a decision table for any given reservoir. So that's what I have input in the model for reservoirs. And then point sources get input into the model as time series of flow at any given point. So these dots are places in the model where it can handle an addition. You can add, it's like at the beginning and an end of a stream unit. So it has a placeholder for a point source at any one of those dots on the stream network. And so what I did was I had information at some level on wastewater treatment works. Some of them have more data, some of them have less data. And so I found the ones that are what point source input node is closest to them, and they're in the subcatchment of it. And I estimated, or I used the data on the flows from that wastewater treatment works out the effluent data, and added it as a point source into the model. I had to do some assumptions and unit conversions and things there because the data has got, you have to give, if you're giving daily data, you have to give every day of the time series that you're putting in. So these are the wastewater treatment works that I got. There's some GIS points and some information about them. As a spreadsheet, there are ones where I had and then I noted what subcatchment they're in and what node point number they're in. So these are the wastewater treatment works. And then I also included a withdrawal and the point source to represent the interbasin transfer between the Moya and the uMngeni from Mearns Dam. And so I had to give a daily flow and a water quality. So you have to give, for these point sources, you give daily flow and also water quality of the flow. Darvel is, of course, the biggest. And for some of them, I had flow data. And for some of them, there was water quality data. And then for some of them, there wasn't flow or water quality data. I just, there was some information on maximum capacity and average, megaliters per day that I got from reports. And so sort of based on that, I used some of the others as estimates to fill, like, so for a lot of the smaller ones that had smaller capacities, or I didn't know what the capacities were, I just used the Albert Falls South as a small, so that may not be the right one to use, but I had to, if we wanted to include these wastewater treatment works, we need an estimate of outflow and what the quality of the outflow. There was, so I estimated flow and I used, so sometimes I used a different station or a different treatment works to estimate flow and estimate quality to give an estimate of the flow out of these ones. So these assumptions on my part may be not the right one, not the right ones. But I'll show you what the input that I would need looks like. So in SWAT for a point source, if you want to do it daily, you can, it's point sources. So it makes a placeholder for all of those points where you could add a point source. So if I zoom to one where, so like this area, for example, around Sidara, there's quite a few wastewater treatment works mapped here. And I assumed that these ones, you know, I only have a stream up to that starts here. Sorry, my JS is lagging a little bit. Let me turn. Just wanted the image on to show you where we are. Okay, that's caught up. You know, so I took the ones that are here, and assume they discharge into the stream network over here, whereas this quarry one, I think I put it over into this side, into this 801 in this stream. It could be that actually this one flows the other direction. So the purple line in this image is the catchment divide, but I think part of my question is if there's any information on some of these other wastewater treatment works where I wasn't given any data on them specifically about what I should assume is their output, or should I even include them in the model? Because the way I've included them now is just to assume they have a similar flow and water quality to some other one where I did have some data based on whether I thought they're small or big, but I don't know much about them. Like other approaches we could take is get some average idea of, you can put in like an outflow that's the same every day instead of having a daily time series. Just say like it outflows this many megaliters or liters per day, and the water quality is on average this, and then it will add, I can do it that way instead of having a time series. So what I put in now for like this point as a point source from these works in sum for 447, I'll show you what it is in the model. So you would then go to your model and you look for point 447. Where is that? Next sheet. Being blind. Okay, there it is. So thinking about it. So for that point, I have the point source flow in cubic meters per day. I have a sediment concentration, organic nitrogen, sediment phosphorus, and soluble phosphorus, nitrates, ammonia, nitrites, oxygen demand, dissolved oxygen, and then the sediment is broken up into percent sand, silt, and clay. So there was data on some of these from the data I received for the works, but it wasn't always in these categories. So I had to do some conversions, like if there's TKN, for example, which is organic nitrogen plus ammonia. And then there would be other measurements. I would split them. I'd do the units conversions to get it into, and this is, I think, yeah, SWAT wants kilograms. I have a conversions table. But I think more important than that, the units part is understanding what, if anything, we should assume in the model for some of those wastewater works where there's not time series data, or is there time series data for some of these smaller ones? Yeah. So like, for example, like for Golden Pond wastewater works is it has a fairly high listed maximum capacity in milliliters per day. And so I picked another one where I had data that was like this one has both flow data. Linfield Park has both flow data and water quality data. So I used it to fill some of the bigger ones where I don't have water quality data. So like Fontaine Prison had this listed capacity of 0.5. And megaliters per day, and Golden Pond had a listed max capacity of 0.8 milliliters per day. I don't know what they're actually outputting. So I just used the Linfield Park data as again for those ones. But it's something to think about in terms of, is that appropriate, or is there other information I could use to have these as inputs? Or we could just not, I don't need to put these in the model necessarily, but they might be significant in terms of the water quality in the streams to include them. Does anybody know about any of these works, or where we should find information about their output? This is one of those things we can't always come back to. It's quite easy to change what's in the model for these. Once the points are there, you just change the input at the point. So it's something can think about, but I have set up the model with a point source inflow into the stream from all of these wastewater works that I have on the list here. But I had to make assumptions about what the outflows were. So I'll document what I've done. And if things are a bit off in the model, it might be because of the assumptions that I've made here. And it's something that can be improved or changed quite easily in the model over time. But I wanted you to know that this is what's in there, and then think about how we can change it for these guys. So yeah, the ones I had good data, or I had some data for, are Albert Falls, North and South, Camperdown, Linfield Park, Gopo, Cool Air. So most of the bigger ones that you're managing. I read that uMngeni is not active yet. So I had it in, I was given the map of where it is, but I just know if I understand that correctly. And then Darville and Howick. And then I had water quality data without a flow amount for Cato Ridge, Abattoir, Hilton College, and Umzinto. Oh gosh, sorry, I realize it's 4. Yeah, so I'll leave it as it is for now. Oh, hi, Ntando.
Sorry, Julia.
Yeah,
Yes,
that's all right.
we are just discussing about the uMngeni wastewater works. It has been commissioned. I think it has started working again. So we'll check for you on the system if they are already recording the inflows and outflows. Then maybe you can
Okay.
use that data to make some estimates.
Yeah. So for these other ones, yeah, you can think about, I know these might be being managed by different, if I understand right, they might be managed by different groups and not UW ones. Is that right?
Yes, most of them are outside of our jurisdiction. As I can see even the Hilton College wastewater works, we once visited it. They are monitoring water quality data, but in terms of the inflows and outflows, they are not monitoring that. And yeah, most of them are managed by private landowners, so it will be tricky to get some data. I'm also looking at the Sedara one. The Sedara wastewater works is managed by the municipality, but it has not been operational for a long time. So inflows are coming in and they all just discharge without treating.
Oh.
Yeah.
Because my as you can see, my assumption here is that these are all pretty small, and so I thought Albert Falls South is a small one. So I just used that flow rate and that water quality, and then like for ones that I thought they were abattoir, there was some water quality from Cato Ridge Abattoir. So I said like abattoir ones have abattoir type water quality, and then school ones had Hilton College type, because there was a bit of water quality data, but no flow for Hilton College. So these ones I just sort of assumed, when I'm assuming from another one, I'm just assuming a seasonal pattern of nitrogen and phosphorus over the year. And a seasonal pattern of flow rate over the year, like very rough, but based on these other ones where there is a bit of data. But I think it might be the best we can do for now for these other ones we don't have data on. But we can look at it when we see how the calibrations and things are turning out. You know, if it's weird in the areas around these ones, it can be about the things that I've assumed here. Yeah. But yeah, if there is information on these that we should use to determine what we should put in the model, then you can think about that. Sorry, this spreadsheet's a bit confusing. This is the part we want to look at, rather than the remainder. So that's what I wanted to go through with you today, so that you have some familiarity of the key types of, sorry, I'm just cleaning up the sheet. The key types of inputs going into the UW model, and the particular ones to think about that we might want to modify to get the water quality representation better are these point sources, and if there are any other point sources to represent spills, like these are just the official wastewater works, but we can add in if there's data on, like, the thing is, to add these spills and stuff, we need an amount, like a flow and concentrations. And so we can try and represent that in some form, but I need more input on how to represent that and where to put them. And I think Jason mentioned that to you in Tando as well, and there was some, I haven't incorporated that yet, but I think there was some work on that I'll try and put in terms of where there were like known spills, and we can look at the impact of them by inputting them in a point source and then seeing how they get potentially diluted down the system. Yeah, and then make assumptions about these other wastewater works inputs. Yeah, I know it's a lot to cover and it's hard to like see it on the screen, but if you have questions, can email, and gonna have some back and forth on this now that you've seen what it looks like a bit more. I've gone over, so I don't want to keep people, but if there's any pressing questions, hi.
Yes, I want to confirm for our wastewater works, the one that's operated by uMngeni Water. Do you need any information from us, or the information that you have is adequate in terms of yeah, because I know that there may be gaps, and maybe the data that you used from I think you got it from Jason through our decision support system. But there are also manual logs that they keep on sites when you go to those wastewater works. Just want to confirm if you're satisfied with the information that you get from our wastewater works.
I think one of the things I struggled with, there's a new set of data that I need to add on to the end that Jason got to me. Some of the older data, like up to 2023, is what I used from the previous one. I think part of it was when there was a gap in the data, what I wasn't sure of is what the gap meant, because the gap could mean that the recording, like, doesn't mean that the station is not, the wastewater works is not actually outputting any water, in which case I would think it needs zeros instead of a data gap, or it means that the recording instruments or whoever's doing the manual measurement, like there's just missing data, but it's still outputting water. So I generally, when there was a gap, I assumed it's still outputting water, and I used averages for that time period. Like
So were those gaps related to 2020, 2021? Because I know that during that time, the COVID time, there was limited monitoring at some sites. But if those gaps are related to that, because last week I did collect a few manual data that from the manual logs that they were collecting around 2020, 2021.
So like, okay, so this is water quality rather than flow. So that's different. When I work with the data and the coding that I do, it replaces all the blanks with NA for no number. So there's equali. So the temperature and the conductivity, like that stuff it's not logged every day. So I smoothed in between the values, between the readings when there's not a reading every day. Let me just open the flow. Sorry, the flow is somewhere else. Point sources, just to show you what I mean. Larval. So I was looking, is this, oh yeah, this is patched. What's my patching? Okay, yeah, so raw. I see where most of the gaps. Darville had the least gaps because it's probably the best operational one. So maybe it's a bad example. Let me go. (2021). So yeah, there's not too many gaps. It's a bad one. Where's one with lots of gaps? Yeah, so there's a gap in, where are we at? This one is Camperdown 2019. So sometimes there'll be a gap like this where I have to just assume that the flow goes up at some, like it, because it starts again at this high flow. You were saying, Nintendo, you were saying there were gaps at 2021. Let me see. Cool air. Okay. 19. Cool air wasn't so bad. Sometimes there was some inflow data, and so I used the relationship between inflow and outflow too. If there's a outflow but there's no inflow, or sorry, if there's inflow but no outflow data, to try and patch the outflow. Or I used the same season flow in the same season. So I generally assumed if there's a gap, it still has outflow. But that's not always the case. This one is, yeah. So some of them weren't so bad. It was just I wasn't sure always how to fill a gap when there was a longer one, like that one I showed in Camperdown 2019. If it's just a day or two, it's not so bad, but when it's a longer, like 2910. Okay, yeah, that's a few weeks, but that's okay. So yeah. And then for the water quality, where there's not a value for every day, I just smooth between the values that there are. And then if there was a bigger gap, I used a seasonal pattern to fill it. I think, yeah, so with that, so this is like the raw data before, and then I would fill it in so that there's a value for every day in the model, because the model is modeling at a daily time step. But then when we analyze like scenarios or how well the model's actually doing, you have to remember that I did that. And so we can't expect it to perform so well at a daily time step when there's so many assumptions, but may see how well it does on a monthly time step. And then you can look at scenarios of events when we do then zoom into times where we do have good daily data without gaps, to look at how well it's doing there. But like we can't expect it to give us good daily values close to the wastewater treatment works when they dominate the water quality and like right close to them, or where the outflow from the wastewater treatment works is quite big. And then I've made quite a lot of assumptions about what the flow and the water quality is from them. But it still can get used in a scenario sense of trying to change it versus trying to change things versus what they are now, if that makes sense, or what the assumption in the model is. Maybe what I should do, yeah, I can add a table that has percentage of gaps in the data for each one, just to show that as an indicator of where uncertainties are likely to be higher or not. Thanks, Nintendo. I think. Oh yeah, I have to go, and I'm sure you probably do as well. But does that answer your question? Thank you for asking me that, and does it answer what you were looking for as well there, Nintendo? All right. So I will send out some more of these summary tables for you to engage with as well. I'll put them on the Google Drive and shoot an email when I've done that. And then we'll chat again next week. Thanks, everyone. This was helpful, and I hope it's helpful to you as well. Oh, I see Sharon's here. I'll email you back, Sharon, about your error. All right. Thanks, everyone. I hope you have a good afternoon. I have to leave. I have something at 4:30 I have to prepare for, so I will. Yeah, I realize I started late. Sorry about that. But I will see everyone next week.
Thank you. Bye.
Thank you, Jennifer. Okay.
Thank you.